Welcome to Bronchi Tech. We're going to talk about wires. So we believe technology is for everybody, and I'm here to share my engineering knowledge with you. All right, so when you're talking about wires, there's several properties you need to think about. And that's your conductor size and your installation. You might have additional components as far as jackets and stuff along that lines, but I'm not going to cover that in today's video. That'll be a separate video because there's a lot to cover here. All right, so the first thing you need to worry about is your amperage on your wire. Each different wire has a gauge that's assigned to it. Now, this is American standard. I believe Europe has a different standard of sizing. We go by gauges. Now, that's the thickness of the actual copper in the wire that's going through, and it's rated for specific current or amperage that goes through it. So a good example is we have a 12 AWG wire, and the maximum current that you can put through that is 20 amps. Now this might actually vary depending on manufacturers, so you need to look at what the actual data sheet says this value is. You need to go by what that data sheet says. Why? Because the manufacturer of these wires have to go through various testing to ensure that their wires meet the specifications. So go by that, because there might be slight variations here depending on your manufacturer. So the one thing, current capacity, you need to worry about amperage. So this is a 16 AWG wire. And if I take a look at this chart, it's going to carry 10 amps. So why does this matter? Well, thicker the wire, the more expensive it is. And you don't want to use a 10 gauge wire when you only have to carry a signal that's giving you half an amp. At the same time, you don't want to go so small that your wire is so easy to break that any movement, it's dead. Now, the second property you need to look at is your voltage carrying capacity. This will vary based upon the wire, and it's based upon your installation. Each manufacturer has a different variation of installations they put around the wire. So voltage likes to jump around. It'll jump around anywhere that it can. And so the stronger your insulation, the thicker your insulation, the more voltage these wires can carry. Now you got to keep in mind when you see the parameters of what is the voltage rating, that's going to vary. And you're going to have both a AC and DC component to that. Usually if it's lower rated wire, it's going to list the DC voltage. And if it's higher, it'll rate the AC voltage, because typically that's what goes through those wires. Now, yeah, I put a good example below. This is 600 volts wire, but it's actually 600 VAC. And what does that mean? Whenever you see an AC current or AC voltage, that's the RMS value of that. That's not the true peak to peak. So DC is your peak the whole entire time. So we always use a square root of 2 factor in order to determine, what is the actual voltage carrying capacity of the wire when applicable. So I have 600 VAC wire right here. And so when we take into account, and if I want to put DC voltage through here, what's the maximum voltage I can put through these wires? Well, 600 divided by square root of 2 is 424. So this is 600 VAC wire with 424 volt DC wire. This might not be specified on your data sheet, but typically if it's higher voltage, they're expecting VAC. If it's lower voltage, they're expecting DC. So when they're testing these, they're going to apply a voltage on the outside direct of the wire right here. So they'll apply a voltage of this 600 volts. They'll apply 600 volts here, and then they turn around and they measure the leakage current on the actual wire. That's how they test for this. They've got more specific methods, but that's a basics. And so when you look, there's different types of wires. I'm not going to list them all right here, but there's a variety of different types of wires depending on your application. For example, you have this TXL wire, which is thin raw cross-linked. It has an insulation of an XLPE polymer. It has a temperature range of -40 to 125. And so the applications for this is tight space, light applications, high flexibility. Now, there's all these vary with price. So you're not going to want to use a heavy duty wire for your little Arduino project. Here's just some more example. If you have battery cable, they have specific battery cable wires for your application. Now, if you're going to put together a boat, they have things called shipboard cable. That's designed to resist the corrosion of what entails with water and everything. So keep that in mind when you're choosing cable. You know, most applications, if you're just doing a little Arduino project, you're not going to need anything fancy like that. I just basically get cheap cable off of Amazon for my Arduino projects. Why? Because that's all that's needed. Now we come down to a stranded wire versus solid wire. This is also dependent on the application. So for a typical stranded wire, you know, like this guy right here, you know, it's a bunch of different wires that are just tangled together to form it. And what are the advantages of this? Well, you have so much flexibility here. You don't have to worry about it moving around like this. The disadvantage is, you know, you have reduced current carrying capacity. So you're going to have a longer, higher voltage drop as you go with distance. And so, you know, this is perfect for things like automotive, things that are moving. You know, if you're moving a lot and you don't have to worry about that voltage drop, you're going to use this type of wire because it'll be reliable for your application. It's flexible. You have high vibration environment, and you won't have to worry about that. One thing that's a pain in the butt about stranded cables is they like to fray. So at the end here, if one of these wires get attached and is dangling right here, and this is a power, and you touch ground with it, you'll have a little issue. This piece of wire will probably burn out, but this is one thing that you really, really have to worry about on stranded wire. So you have different mechanisms to take care of this. So this is like a ferrule, and it gives you the capabilities to take all these stranded wires and feed them into here. And you crimp it off. Now this will be typical for stranded cables. You'll need something to be able to terminate this on the other end. You don't necessarily need that for this wire. They make all different types of devices for those. You got ferrules, then you have solid wire. So this is more expensive. Now you have solid wire. You know, this is one solid piece as shown, and it's not as flexible as the other wires. So, you know, after you bend it in the same spot once or twice, you can't bend it again because that's how the wire works. And so it's not a good application for if you're driving it, if it's for automotive, because over time, the constant vibration, this little single piece will end up breaking or reducing the current carrying capability. And so this is really good for long distance applications, and it's good for your house. Your house never moves. This is what your whole entire house is made out of. And in applications where voltage drop is actually an issue. So a good example is the good old-fashioned RF cable. So this is a single wire cable, and it's specifically designed with the intent of reducing the noise completely into the system and the voltage drop. So it's designed to have, what, 50 ohms attenuation throughout the whole entire wire. So when you terminate this, there's no power loss and you don't have echoes. I mean, this stuff matters for applications like this. This is also one little tiny wire with a thick cable. It's not flexible. It has some flexibility, but it's the use case that it's there for. You know, if you go through and you have audio, solid cable will give you the best sound. And then you go to other cables, like this HDMI cable. Now this is one solid piece, but it's all stranded wire. Why do they use stranded wire? Well, it's a digital signal. You can either have a 1 or a 0, and it sends through, I don't know what it is off the hand. It's either 3.3 or 5 volts. And so you have a lot of voltage drop that can happen within this cable, and it still work just perfectly fine. That's kind of why everybody's moved away from the analog world to the digital world, because this is easier to make. It's more cost effective. This guy. Same thing with your Ethernet cable. You know, it's stranded wire. Why? You need a 1 or a 0. I believe it's 3.3 volts going through. You know, if it's below a half, if it's below 1.5 volts, whatever it is, it's a 0. So this gives you a lot of margin in your design as far as the cable. And so thank you for tuning in today, and I hope you enjoyed this video. I'm going to try and keep putting out more videos, share knowledge, and enjoy your day.